In version 23 we've added taper compensation. Now this is mostly going to be used on water jets, although it can be used on other machines such as the plasma who might need to do this. If I open up my part in the 3D world, I'm going to turn on this show bottom toolpath just to be able to demonstrate this a little bit better. And when I apply a toolpath, you'll notice that I get a green toolpath on the top of my part, and then when I switch to the bottom view here, it's a yellow toolpath, and that yellow toolpath is right on the edge of the model. And that's normal. So when I go to simulation now for this circle that doesn't have any bevels on it, and I look at my rotor and tilt, they should be at 0 because I don't have taper compensation turned on right now. But if I open up my rule manager, we have a new setting for taper angle rules. I'm going to turn that on, and then I'm going to open it up and show you a little bit. Under these rules we have our typical criteria so that you can separate out and create rules for different material types and different thicknesses. And the reason that somebody might do that is because of the taper that they see on different materials and thicknesses could vary. So I'll open up my rule, and I've set my max angle adjustment to -5, and that's so that in this demonstration you can really see the difference. So now when I apply NC, I get that same green and yellow toolpath. But when I switch to the bottom, you'll notice that even my straight cut hole now, the yellow toolpath is offset a little bit. And then there on this edge, we're offset as well. So I'll switch back to this view and simulate this, and I'm going to switch to this view here so that you can see that the rotor and tilt now are adjusted as we cut around this straight cut circle. So for this straight cut circle, we're cutting it with a -5-degree angle, with the expectation that when we're done, that circle will be perfectly straight with no taper at all, and then the rest of our bevels here will all come out at the defined angle as opposed to offset by a little bit because of that natural taper. And as we finish up our simulation, we'll click done and send this part back to SigmaNEST in our 2D view, and you'll notice that the red and gray lines that are typically there for a bevel are offset by a little bit, and that is exactly where our taper compensation is coming into play.